So some of the steps have been given that first of all we have to mark the railway station in and also surrounding the catchment area like the present polymer method. Also, here the rainfall amounts, rainfall magnitudes given at the station location. So we have to draw the ISO height by some linear interpolation between, because some of the points are there, and to the scale we'll see between the adjacent drain gauges. Like contours also we have some value, some in between linear interpolation. Here also same thing, and in between, because some points will be there, some in between points are linearly interpolated, and we have to draw some smooth curves. This isohedral method, so it's graphical and takes some time also, and but it is accuracy purpose. It is if done correctly, it is accurate. Like the Thyssen polygon is accurate also, and particularly if there are a number of ring gauge stations, but it requires if we have more number of ring gauge stations, then it's good to prepare the ISO heights. So most of all, either we'll use Thyssen polygon method or this isohedral method. Sometimes if we have a large number of ring gauge stations, and we can draw it. So suppose this is a catchment boundary, how this steps river have been given here. So this is the catchment of the watershed boundary. So these are the locations. So the rain gauge stations values are there. Values are in inch is given. So whatever maybe a unit is not important, but the values, like here we see 2, 3 values are there. 3 means the magnitude here. It is the 4, 5. So these 4 rain gauge stations, these precipitation values are there. Now here we have to join. Here it is joined. This line is say 3, 4, 5 here also, and to this scale actually. So that is here 3.5, 4.5 that is marked. Here also 3.5, 4, 4.5 because it's, so it is marked. So we get like 3.5, these 3 points, here 3, 4 in between 3.5. So as many number of points we'll get, that is good. Here 4, here 4.5. Now we can join this. So there is 3, there is 3.5, okay. And then there is 4, okay. And then 4.5, and finally it is only 5. So these lines are joining through these points actually. And finally, the average precipitation, it is calculated by here also, like the Thyssen polygon method, we have utilized the formula like P1A1 plus P2A2, like that divided by the whole summation area. Summation area is obviously here also the catchment area. But the precipitation values here we see now, if these are the values of ISO heights like here suppose 3, 4, 5, these are the ISO height values, the rainfall magnitude values. And here area means to say we are calculating the inter ISO height areas between the 2 ISO height. So here is suppose here you see A1, A2, A3. For the last case it is the these ISO heights and the catchment boundary, this area, and for the in between this is the isoheightal area between the 2 ISO heights. Here also. So average precipitation, here summation AI Pi by summation AI. So that has been done, but here AI means the inter-isohyet area, but what is about the precipitation values? That is of the average of the two isohyet values. Average of the two isohyet values multiplied by the inter-isohyet area. So that's summation for whole catchment divided by the total area. So we calculate the precipitation by this formula. You can write the formula, this formula.
Ma'am, please explain the terms of the formula.
Yes.
All the terms in the formula, there is small a and capital A. What is
Capital A,
ma'am?
just now I told you, here every symbol is not written, but actually here you see P1, P2, here it is written already. This one, what I told, these are the values of the isohyet.
Now, what is AN?
And these are the, actually it should be small a anyhow. This is actually that are the all the inter-isohyet area. If you see this formula, inter-isohytal area multiplied by the average of the two precipitation values. You see here. Divided by area is always the whole catchment area. Capital A is the whole catchment area.
Ma'am, actually the problem in the numerator, first two terms are similar, but the last term does not look in the same way. That is the thing.
Okay, leave it. Right. Sorry, this has been, it should be small. Yeah, last time you can write here actually, if you write, if I understand, you can write instead, it is an minus 1 into pn minus 1 plus pn by 2 actually. If I want to write in the same manner. So now we'll see this example problem. So these are the isohyets due to storm in a catchment. This has been shown.
Ma'am, how is isohide drawn?
That's now here I explain. Na? So it is to scale, actually it should be that like a 3 to 5, in between one is you have to mark those points, and then you have to join the same levels with the same magnitudes. You have to draw it like that. You have to join with the curve. So actually, as many number of points if you get, the isohyets will be good. So here we see some of the stations. Station point values are given there. These points, and these are the isohyets 4, 6, 8, 10, and this is actually one closed one.
I'm 8.84 centimeter.
Oh, I've calculated good. Who was speaking?
Yes, ma'am. Satya Pratap.
Satya Pratap, yes. 8 point. No, I think it is 8 point. So here also just averaging, only here you take 12 only, this value. Other values are averaging, and this is the interisoidal area. So other students?
Yes, ma'am, got it. 8.84.
8.8. Yes.
Yes, ma'am.
8.84, Sati, not 4.
Yes, ma'am, 8.84.
Hmm. Okay, it is 8.84 centimeter. So here actually this AI by A has been done separately, but you can do that also, no problem. And AI by A has been done this one separately, and then PI into AI by A it is added. So it is 8.84 centimeter. So I think so you have solved it. Most of you have done it. Vritti Sundar,
Yes, ma'am.
done.
Yes, ma'am.
So Shati, you got? Shati is giving no response.
Yes, ma'am.
Got it?
I got it. Yes, ma'am.
Okay. Okay. So next, so we have theoretically so this double mascara is solve the graphical possible. So we'll see a problem. The double mascara. So this is the problem statement that annual rainfall data for a particular station is given, as well as the average rainfall values are also given. Okay. You can write this problem later on. The data I have already given to you, because there are some 30 years data, I think. So to test the consistency for the rainfall data, and if there is discrepancy, correct the record. Data given.
Ma'am, please wait.
Just
I'm done, ma'am.
yeah, okay. Okay, so all of you have downloaded the Excel file.
Yes, ma'am.
Okay. Then just open the file. So this data you have in the Excel. Okay. Moving to Excel. So now start solving. To start with, first of all, for any sort of problem of this double mass curve, we have to arrange the data in the descending order, the year. That means the latest year will be at the beginning. So first of all, so this data is there. Okay. If you open in the Excel, so select all the data. And then go to that one. I think here data, you have to sort. The last time I showed you data sort. You click here this sort option. Here you have to sort by which column. Here year, that title year. Then sort by, you choose year. Order is, sort on syllables is okay. Order is largest to smallest. So this is just sorted. Okay.
Can you do the last step once again? Which column
Yes.
you sorted?
Just it is the original data, okay?
Yes, ma'am.
Given in the problem. So it is year, annual rainfall of station X, and the average annual rainfall of the group, means the base, the neighboring station. Now we'll arrange the data in the descending order of the year. That means this 1990 to 2019 data will be at the first. Just it will be arranged reverse. So Excel, there is an option. Don't have to manually do it. We select the data, and here in the after this data option, after formula, there is one data menu. You go to there one option is there, sort. If you click this data, you'll get this sort option. In the sort option, then use column sort by year. Because there are 3 columns. We can sort by some values like that, this column, but here only sort by year. So order is small, largest to smallest. That means the latest year will be first. So largest to smallest. So if this one you have done, then just click OK. So this one I have done.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So this is any problem actually. This data sorting, this is one advantage of Excel. Any number of data you can sort. So now it is sorted from the, let's say 2019 to the back years 1990. Now, as for the double mascot, we have to keep the summation of values. One is just we can tell here sum of x means I'm just telling sum of precipitation at x. And sum of the precipitation, these value summation. Column. Two summation values we want for plotting. One this summation value, another this summation value. Okay, first let me do sum of this P average value of the group. So this is so first one it is same 1588. The next one is so just summation value. Next this plus this. It is the cumulative values. So these are the summation. Don't take this. This is the first one. So this is formula. It will not take time. Last value will be 18,396. You can check it.
Ma'am, can you show again?
Yes. It is the summation of this means cumulative values of this column, average annual rainfall. Okay. So
Okay, ma'am.
first one, like the cumulative normal rainfall we have done in the normal mascot. So that was given, but here we have to do cumulative. Here first one it is 588. So it is next one it is 588 plus 410. It is from assumption. Next one it is this plus 988 plus this one up to that here the summation values. So it will be 998 plus 787. Either to calculate if 3 summation that way also you can go since I've already done 2. So that's why 1 this way. Anyway, you have to set the formula, that's one. So next one will be this plus this one. Now understood?
Yes, ma'am, done.
Done, ma'am.
Yes, ma'am, done.
So now I need to cell you click and drop it in. So similar is for the first one. This will be actually this column sum only station X. The first one it will be 612. Next one it will be 612 plus this one. Then this another one calculation. It's two calculation you can have to do. Then you can drag and drop it. So this one. The last one will be 17,060. Okay,
Done, ma'am.
done. So it is simple summation. No problem. If Excel is there, otherwise you think if we have to do manually this calculation, how much?
And what is the last value? 17060.
Yes, 17,060 for summation Px and P average it is 18,396. Okay.
Yes, ma'am.
Okay, since Excel is doing so, there is less chance of if you set the formula correctly, it will be correctly calculated. Otherwise, by hand, there is chance of mistake. So many summations are there. Anyhow, so now we have to plot that here, little bit is like we have to plot, but there you, if you remember the theory, they told us that actually the set it is the plotted. So why I have plotted this one summation. So this should be in the x-axis. This will be in the y-axis. The P average summation will be in the x-axis. The P average of the surrounding station and the station, that particular station, that will be in the y-axis. And we'll see where the slope break is there. And so that's why the initial station, the latest year starting, and where the slope break is there, we'll identify that slope break, and that so the latest year slope will be there and change with the slope. Now, so first of all, since it is actually this is what is there actually if we have to now you so to plot in Excel, if manually you can plot, we can draw some points line, we can extend it and see where is the slope is breaking, we can understand it in that way. But here Excel actually if continuously you can draw a line, it will give a single slope of it. So better to first, because we don't know where the slope break is there from the data. This is the XY data. So firstly, to have an idea, just plot some scattered point. Plots, first of all, because the points will be scattered points somehow. Okay. So this one you could have plotted manually also, since so many points are there. If you can manually plot, you can understand also, particularly this one. Anyway, for this one, so you see something, I think from here up to this we can take one line, and here some little bit change type it is shown. So it is showing like this will be one type of slope and this will be some little bit change. So if suppose up to this point we take, we can, if we click, put our mouse button there, we can see there's some 0.69016972. That means it is pointing towards up to the 2007. Okay. So what we can do, that this 2007, actually, since we have to join the line, so if we have drawn in single series, then we can get a single line. So first of all, to get an idea, so 2007 up to this one, 6901, 697 to this point we have identified. So suppose this one, now I just delete the points. Okay. So first see, then you can do yourself. Now I select the data, or you can just draw, I can take up to this data also, 6901, and same where I can draw a scatter plot. If I can take this one. So up to this one, 2007, I have, okay. Now again, in the same plot will do. Select data, this was series 1, and add any series to any name you can do it. Now, series X values. See, now I plotted separately in a same graph only, but up to some this 2007 I plotted, then after that I plotted in the separate series. Understood?
No, ma'am.
Ma'am, why are you not drawing line?
That is
Ma'am, repeat once again.
actually, later on I'll tell you to solve this type of problem if you have, now it will take time, otherwise I'll tell you
I'm done.
if you have normal. So suppose A, why I am not, I will now get the line equation of the line. Because if that time I have, I could have got the line in the same series, all the points, then I'll get one single line. It will give the Excel that has the option, that trend line option, so it will give a single line. But here, why I am showing, if you remember the theory of the double mask curve, it is that where is the slope of the line is changing. I'm showing you this, but I think before a little bit maybe you have forgotten by this time if you see. That was in precipitation. I think today only I send you the notes. That see, this is the thing. There are initial points. So these are the points where we want to find this change in the slope of the line. This was like the latest years were starting. So that's why I have sorted the latest year at the first. So this change in the slope we have to identify. And this change in the slope, we're assuming that the latest years are correct in the record. And if that slope we can take, so that is actually then corrected, that C by A, that is the corrected slope, means the same slope of the latest year's record. So if I am joining with the, here in the plotting, if I am joining with the same line, so it will give the I cannot identify the break.
Got it, ma'am.
So that's in that objective I have drawn. So, but first of all, we have to understand because where we have to break. So here, why visually we have to understand actually, if we plot in the Excel. You can solve this problem also in arithmetic graph paper. Later on you do.
Ma'am, how do you add the latter points means after 2007?
You can, if you have plotted these points,
Yes, ma'am.
then in the same chart, you can put a number of series. So you right click and select data. You add one series here. I have already added. You add one series. Suppose any add one series. Name is not important. Series X values you choose here. Select the X values here. Series Y values, you select the Y values here.
Ma'am, in X values, what should I choose?
This one. Here from 2006 to the back years. X value. You have to choose like that. Series X values you choose here.
And
2006 to this one. Then Y values you have to choose this one. Then like this. Then click OK. Then it will come, and here also OK. Then it will come like this. Are you getting it?
Yes, ma'am.
Okay. Now you can join the line. Okay. So this change actually. Like hand when you are drawing, we can change. Okay, so this is the change you can see there. This is the, now you right click. First series right click and add trend line. You have to linear line. So to get the slope, we can display the equation. So it is giving up some equation like 1.0171. Okay. And now series 2 also. You can add separate line. See whether you are getting this type of equation or not.
yes, ma'am, getting.
So it is y is equal to 1.017x plus 43.7 nearby, right?
Yes,
Ma'am,
ma'am.
but in my case, it is getting 0.8777.
Oh, that is not okay. But are you getting this series 2 from, I think I have taken from 2006.
Yes, ma'am. Yes, ma'am.
You have taken also from that?
Yes, ma'am.
I don't know what Excel, it should give the same equation.
Ma'am, same results coming.
I'm getting the same, ma'am.
Yes, ma'am. It is
And-
changing from 4th point, I think. So it doesn't matter. Ma'am. It's correct.
Anyhow, that doesn't matter. Okay. So see the equation. So that's why now we can understand if we have drawn in the same series, we have several lines. So we cannot identify the break in the slope. Okay.
Ma'am,
Now we
what
have to
option
find
for-
the
Excuse me, ma'am,
Yes.
what option for that equation?
equation is any line, any scattered plot. If you join the lines, so normally drawing for Excel in any best fit line also here, the lines are joining sometimes for best fit line also. You just right click the series data like this, okay? Now since I've done, okay, later again, I'm showing you for this series too, same procedure for. You select the set of data, right click and add trend line. Okay. Just it is, here it is linear. Display equation on chart.
Okay.
You can get that. Okay. We have some calculation. Okay. So this one now, this chart title, you can put here double mask curve and here you should put the axis title. Axis title. Here you can write that cumulative 10 station average. And here cumulative annual rainfall of the station X. So here both are in millimeter unit. So that's why this is, see, in the both axes, it is the same precipitation values. That's why the name is double mask curve. Now, better I move the chart and place some new sheet as chart 1 because I left some calculation. Anyhow, this is like this one, you can change the style and all those things. So now you see this part, this is up to 2007. The whatever part, this is up to 2007. And this is 2006 to backwards. So this line slope should be corrected with this one. Okay. So corrected line slope is this 1.0171 and this is 0.8774. So what is the ratio of this slope? This y is equal to mx plus c. So this y 1.0171 divided by 0.8774. You calculate that ratio.
Ma'am,
This
1.1592.
1.159.
Yes, ma'am.
Yes, ma'am.
Okay. So Now, so this way you have to find that correction ratio actually. Now, the values, we have to adjust the values of the this one, not from here, 2000, this was up to 2007, no? Yes. So if it is 2006 onwards, so 8041 1971, so 79, so it is 2006 onwards, we have to do the correction values. Have to correct the values. So 2006 onwards, so this is, we should write corrected or adjusted corrected values for station X. So this, now come to this annual rainfall values from where we want to change, the slope has been changed. So there, I've seen from here, the values should be changed in that, this, see that precipitation value multiplied by this correction factor. So here suppose this is 999 here. Multiplied by either 1.159, you can directly write, or otherwise you have to take dollar anyhow. There 1.159. So for everyone, here it is. This one multiplied by 1.159. So just now go to the original annual rainfall values and the correction. So I've done it?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. So see in the problem actually the last one is I estimate the average annual precipitation at station X. So final values. Just before that, whatever this data is there, you can just copy this data and paste in this column. This one, and from here, adjusted values. This one just you can round off also. You can take the decimal place also, but since the earlier values are rounded of these values. So if we just round off a number of digits, some round function is there. It is if you, the round function, this value, any decimal number and 0.
Ma'am, how you did that?
That is some round function. That is round of actually any decimal number. If we want that, if we place this round off, you select the cell. You see here the cell is selected, comma, you have to give the number of digits. Suppose 3 decimal, we can place 1, 2. Since I want to here after decimal no place, so that's why I put it 0.
Done, ma'am.
Okay. So now what because that average we require all the values of these are the there and corrected values. So get the summation of this column. If you put summation, this sum function here, it is already chosen the cells. Otherwise, you have to select the cells. Here it is already chosen the cell. This is 18663. So this is the total. So we get that average rainfall or precipitation of this station X corrected value. So that will be this divided by, we have how many number of years of data? I think it's 30 years. No? 3 to 32. That means 2000.
Ma'am, we can use count for that.
Yes.
Ma'am, for calculating the total number of years, we can use count.
No, sum. It's sum
No,
function.
ma'am, for calculating the number of.
Oh, number of that you can use. Count that also you can use. Anyway, here I'm seeing this 30 years data, 1990 to 2019. You can use that. $622.1. So 622.1 mm. Oh, we can also use, so you got it, 622.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
There are all these formulas are there. So this one I have used even actually that even you can use only the average function. That's why I use this is the average function. Average function, and if you select the cell, so that will automatically give you. Don't even to count the number of things. Average of all the cell values it will give. Like that you can do it with this average value, corrected values. One minute. So I've learned many application of Excel in this hydrology. So precipitation chapter is this part somewhere. There are some other part frequencies. This for presentation of data, computation of average precipitation. This is completed. Okay, so today I end here because the next topic into better. Not much time is also there.